Hi everyone, in this video we'll take the power rule of integration, which is integration of x power r dx equals x to the r plus 1 divided by r plus 1 plus c, where c the constant of integration, and this case when r not equals to negative 1. When r equals to negative 1, you will see this case in the next example. Our example is evaluate the following integrals. In part A, we have integration of x to the 10th power dx. As the power rule of integration, this is equals to x to the 10 plus 1 divided by 10 plus 1 plus c. And this is equal to x to the 11th root divided by 11 plus c. Now in part B, we have integration of x to the negative 7, and as a power rule says this is equals to x to the negative 7 plus 1 divided by negative 7 plus 1 plus c. We can simplify as x to the negative 6 divided by negative 6 plus c. Since we have negative exponent here, you can put x to the negative 6 in denominator to get a positive exponent, and you will get negative 1 over 6x to the 6th power plus c. Now in part C, we have the integration of a fraction, and the fraction is 2 over 5. Then you can apply the power rule for this case, and you will get x to the 2 over 5 plus 1 divided by 2 over 5 plus 1 plus c. Now we can simplify more by rewrite 1 as 1 over 1 and multiply by 5 to rationalize the denominator. Multiply by 5, multiply by 5, and you will get x to the now 2 plus 5 equals to 7 over 5 divided by 7 over 5 plus c. Now since we have a fraction and denominator, you can put it down and flip the fraction. Then you will get 7 over 5 x to the 7 over 5 plus c. Now since we have x to the 7 over 5 in our final answer, you can rewrite this exponent form as a radical form. So we can write 7 over 5 multiplied by the 5th root of x to the 7 plus c. In part D also we have a negative fraction, so this is equals to x to the negative 3 over 10 plus 1 divided by negative 3 over 10 plus 1 plus c when we apply the power rule of integration. And again you have to rationalize denominator since we have addition of two fractions. So multiplied by 5, multiplied by 5, and here multiplied, sorry, not 5, 10. So you have to multiply by 10, multiplied by 10, and here also you have to multiply by 10 multiplied by 10, and you will get x to the power, we have negative 3 plus 10, which is 7 over 10 divided by 7 over 10 plus c. As in the previous part in C, also you have here a fraction and denominator, so you have to flip the fraction and put it up, so you will get 10 over 7 multiplied by x to the 7 over 10 plus c. Now we can rewrite x to the 7 over 10 in radical form using this formula, and you will get the final answer: 10 over 7 10th root of x to the 7 plus c. Now in part E we have the integration of 1 over x to the 9th power dx. Here we cannot apply directly the power rule of integration, so you have to modify the function inside, and we can use this formula. So 1 over x to the n equals x to the negative n, so we can rewrite it as integration x to the negative 9 dx, and now we can use the power rule of integration to find the integration we have. So we have integration, x to the negative 9 plus 1 divided by negative 9 plus 1 plus c, and you have to simplify. X to the negative 8 divided by negative 8 plus c, and here we have a negative exponent, so you have to put it down in denominator and change the sign, and you will get minus 1 over 8x to the 8th power plus c. Now in part F we have the cube root of x squared dx, and you have to integrate this function. So first you have to write this radical as x power something, and you will get x to the 2 over 3 plus dx. Now you can apply the power rule of integration, so this is equal x to the 2 over 3 plus 1 divided by 2 over 3 plus 1 plus c. Now you have to rationalize the denominator, so divide by 1 multiplied by 3 up and down, and you will get x to the 2 plus 3 equals 5 over 3 divided by 5 over 3 plus c. Now since we have the fraction 5 over 3 in denominator, so you have to flip it and put it up, and you will get 3 over 5, and you have to change x to the 5 over 3 and put it in radical form, and you will get the cube root of x to the 5 plus c using this formula. Now in part G we have x to the 6 multiplied by square root of x power 5 dx. First you have to modify the integration before you start the integration. So this is equals to integration of x to the 6th power multiplied by, now square root we can write it the second root of x power 5, so we can write it as x to the 5 over 2 dx. Now as you know, if we have x power m multiplied by x power n, you have to add the exponent and you will get x power m plus n. So we can apply this fact in our integration, and you can rewrite the integration as integration x to the power 6 plus 5 over 2 dx. Now you have to rationalize the denominator, 6 over 1 multiplied by 2 multiplied by 2, and you will get integration of x. Now 2 times 6 equals 12 plus 5 equals to 17 over 2 dx. Now you can apply the power rule, since we have integration x power something, and you will get x power 17 over 2 plus 1 divided by 17 over 2 plus 1 plus c. And this is equals to, now this is divided by 1, divided by 1, multiplied by 2, multiplied by 2, and you will get x to the 17 plus 2, which is 19 over 2 divided by 19 over 2 plus c. Now in this example we will deal with the case when r equals to -1 in the power rule of integration. This is our rule. The integration of x to the -1 when power equals to -1, the answer will be ln absolute value of x plus c. So this is the case when r equals to -1. Why this rule? As you know, the derivative of ln x equals, in general, derivative of any ln function is the derivative of the inside function divided by the inside function. So the derivative of the inside function divided by the inside function, and derivative of x is 1 over x. Since the derivative of ln x equals 1 over x, if you integrate both sides, the integration will cancel the derivative, and you will get that ln x equals integration 1 over x dx. Now to ensure that the quantity inside ln is greater than 0, since the domain of any logarithmic function must be, the inside function must be greater than 0 for any logarithmic function, you have to put absolute value here to get a positive value. So integration of 1 over x is ln absolute value of x, and you have to put plus c, which is the constant of integration. Now we have one example in this slide, and you have to find the following integral, which is integration of 1 over x. Now, as you know, you have to modify this function, and you can write it as integration of x to the -1 dx, and as this rule tells us that the integration of x to the -1 is equals to ln absolute value of x plus c, and that's it. Thank you.